Hi guys, now we're going to classify polygons a little bit more. We're going to actually do some definitions that are really critical for second semester. The first one is for a polygon with all of its sides congruent. So remember, when we have a triangle with that, what did we call it? Notice I marked it right away. An equilateral triangle. So we're going to call it an equilateral polygon. Now with like a quadrilateral, that means you're going to have a rhombus, but an equilateral means all the sides congruent. So what do we call a polygon with all of its angles congruent? Yeah, we're going to call it equiangular. And again, with a triangle, we already knew that definition because we use that to classify it real easily. What would that be in a quadrilateral? Well, that would be a rectangle. The definition of a rectangle is a quadrilateral with 4 right angles. But here's the one that's probably the most important, and we use it a lot, is a regular polygon. A regular polygon is a polygon with it that is both equilateral and equiangular. And some of you already realize that would have to be the case for triangles that are equilateral and equiangular. But also, that's a square with quadrilaterals. And you guys, we haven't even defined that, but most of you already know through previous years what that is. Now, when we have regular polygons, what that allows us to do is to get a very tight definitions on things. And we know they're always going to have to be convex polygons when this is the case. And so when I work with it, regular lets me know everything's the same. So when I do this, it says to find the measure of one interior angle of a regular polygon with n sides, we use the fact we can find the sum and then divide the whole thing by n. Now, I don't use that all the time because it's actually easier to use the exterior angles. But let's get the next theorem and we'll see how that works. This one's called the Polygon exterior angle sum theorem. So we're going to add the sum of the exterior angles. Now, the sum of the measures of the exterior angles of a polygon, and this would be a convex, okay? One at each vertex is always 360 degrees. Now, here's the reason why this works. If I would go around and use my linear pairs with the interior and exterior angle, this would be, excuse me, I'll make sure I write the right one here, 68 degrees. Over here it'd be 51 degrees, and over here it'd be 132 degrees. If I add those all together, and those are exterior angles, so 109 plus 68 plus 51 plus 132, you're going to get 360 degrees. Now notice the same thing actually happens with our triangle here. Let me move this here real quick. We do the same thing, and I know this one's 95 degrees, this would be 115 degrees, and this one over here is 150 degrees. So we go 115 plus 150. By the way, that's right, 265 plus 95 degrees. It's going to be what, my friends? 360 degrees. So it works out really well. So no matter what, the exterior angles are going to add up to 360. Now what that allows us to do is actually find interior angles really quickly by using exterior angles to our advantage. So the first thing is, it says we have a regular 12-side polygon, so we know everything's the same. That means the number of sides, n, is going to equal 12, and we're supposed to find the following. The sum of the interior angles. We go n minus 2 times 180. So I'm going to go 12 minus 2 times 180, so it's 10 times 180, which equals, in this case, 1,800 degrees. Now remember, that's 12 angles all being added together, so that makes a lot of sense. Then the next one says find the measure of an interior angle. Well, if I know the sum, of all of the interior angles, all I have to do is divide by 12 and get that to be 150 degrees. Now that's one way of doing it. Now, the easiest way to do an exterior angle is actually to use the sum of all the exterior angles. So to find the exterior angle, I would just go 360 and divide it by the number of sides. So 360 divided by 12, that's going to be 30 degrees. Now, you know if you've done this right if your exterior angle, which is 30, and your interior angle, which is 150, both add up to 180 degrees, because exterior angles and interior angles are going to be linear pairs. So it does add up to 180, so we know you did this right. Now let's do the next one. It says find the measure of an interior, find the sum of the measures of the angles of a given polygon. If they don't tell you what angles they're looking for, they're talking about interior angles. So we're still going to go n minus 2 times 180. So we got 14 minus 2 times 180. 12 times 180. Notice I lined everything up with this, my friends. We get 2,160 degrees. Then we have a heptagon, which remember n equals 7. Remember n equals 14 in this case. So we go n minus 2 times 180. So 7 minus 2 times 180. 5 times 180. We're going to get 900 degrees. All right. Now, next one. Read carefully, and if you mark your diagrams, it'd be a lot easier. It says, the measure of an interior angle of a regular polygon is given. Find the number of sides. So these are all interior angles. All right, so interior angle, and it's a regular polygon. That means they're all the same. Now, I'm going to show you the fastest way of finding the exterior angle, and it's not going 360 divided by the number of sides. To find the exterior angle, use the fact that if I have a polygon drawn, let's say something like this, and this is, going up, here's your interior angle, here's your exterior angle, they're a linear pair. So I'm going to go 180 minus 120, which is 60 degrees. So our exterior angle is 60 degrees. Now, then I'm going to find the number of sides. To do that, to find the number of sides, go 360 divided by the exterior angle. But this only works if it's a regular polygon. So I'm going to go here and go 360 divided by 60, which is 6. So we have a hexagon. Do the same idea here. If I'm going to find my exterior angle, just go 180 minus 108. That's 72 degrees. To find my number of sides, I'm going to go 360 divided by the exterior angle. So I'm going to go 360 divided by 72, which gives me 5. That's going to be a pentagon. My exterior angle here, which is going to be 180 minus 135, which is going to be 45 degrees. How do I find n? 360 divided by 45, you're going to get 8. So that's an octagon. So notice it's pretty simple to find these if I know exactly which ones I have. And it's all because we have the regular polygons. Now look at the next problem here for me. It says the measure of the exterior angle is given. Exterior angle, exterior angle. Find the measure of the interior angle and find the number of sides. Well, I'm actually going to find the number of sides exactly the same way that I did before. But the interior angle is really easy. It's still a linear pair. Interior and exterior still make a linear pair. So I go 180 minus 60, which is 120 degrees. To find n, I'm still going to go 360 divided by the exterior angle. 360 divided by 60, that's still 6. Notice these interchanged. I just did a little bit different process. So the a on each of these are very closely related. So here's my exterior angle. To find the interior angle, we're going to go 180 minus 40. It's 140 degrees. The number of sides, we're going to 360 divided by exterior angle. So 360 divided by 40, it's going to equal 9. So we have a nonagon. So kind of cool. Works really easy. Now, this is the sum of the measures of the angles of a polygon with n sides are given. Find n. Now this is our n minus 2 times 180. So now we're going to do some algebra and we're going to work it backwards. We're going to go n minus 2 times 180 equals 1440. Now we can solve for the number of sides doing this. So the first thing I'm going to do, makes it a little bit easier, so I'm going to divide by 180. So I get n minus 2 is equal to 8. So n would equal 10. So that's a decagon. Now, you could do it a little bit differently. You can get n minus 2 times 180 still has to equal 1980. But you could go ahead and distribute. You can go 180 times n minus 360 equals to 1980. Add the 360 over. And so I end up by getting 0, 4, 3. So it would be 2,340. Divide by 180. Divide by 180. And you're going to get n is equal to 13. So it works the same way. I prefer the first way of doing it, but either way works. Now guys, all these type of problems could be possibly on your test, so make sure you use these to study. You'll do a great job.